Okay, let me show you the answer of tutorial 4, number 1. So a small firm builds two types of garden shed. So type A requires 2 hours of machine time and 5 hours of craftsman time. So type B requires 3 hours of machine time and 5 hours of craftsman time. So each day there are 30 hours of machine time available and 60 hours of craftsman times. So the profit of each type A shed is 60 ringgit and on each type B shed is 84 ringgit. So formulate the appropriate linear programming problem and find the number of type A and type B shed that can be produced daily in order to maximize the profit. Okay, now to answer this question, so you need to know first the x and y. So from here, if we know the objective function, then it will be your x and y in your objective function. So first thing, you have to find what is the objective function. So from here, we know to maximize the profit. Okay, so we need to maximize the profit. Okay, now because of to maximize the profit, so the objective function becomes the profit. So the profit here is each type of A shed and each type of B shed. So means that your X is type A shed and your Y is type B shed. Okay, so from here the objective function that you can get from the sentence here is 60x plus 84y. Okay, now from the sentence we bring out into the table because of we want to make it easy to make the inequalities. So from the sentence of this sentence, starting from this sentence, we know that type A requires 2 hours of machine time, 2 hours of machine times and 5 hours of craftsman times, and then B 3 hours of machine times, so 3 hours of machine time and 5 hours of craftsman times. Okay, now each day there are 30 hours of machine time available. So machine time just have only 30 hours, so it is less than 30. And then for craftsman times we have only available 60 hours, so means that it will be less than 60. Okay, so we will get two inequalities from the table. So from this, so you need to rewrite the constraint. The objective function is here, and then the constraint, the first inequalities will be x and y must be greater and equals to 0 because of x and y is a quantity. So number 2, we have from the table, so we got 2x plus 3y less than equals to 30, and then number 3 is 5x plus 5y less than equals to 60. Sorry, 60. Okay, now from the inequalities we need to find the point, because we need to form the straight line function. So to make it easy, so you just put a box beside your inequalities x and y. So just substitute when x 0 and y equals to 0 into each of the inequalities. So when you substitute x equals to 0 here, so you got y equals to 10, and then when you substitute y equals to 0 here, so you got 15. Okay, same as below. So the second inequalities, so just substitute x and y equals to 0 in your inequalities. So when x equals to 0, so you got y equals to 12, and then when y equals to 0, so your x equals to 12. Okay, now we have 4 points in your graph. Okay, in your graph. Okay, in your graph, okay, say here is x-axis, and here is, okay, here is y-axis, x-axis and y-axis. Okay, so first step is x and y-axis. Okay, now use your scale. So 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here is 10, and then here is 12. Okay, and then we have when x 15, y 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here is 12. 13, 14, 15. It's 15. Okay, now to form a straight line, so we got 0, 10 point here until 15, 0. So 15, 0 is here. Okay, so one equation, and then another equation. 5x plus 5y equals to 60. So when x 0, y 12. When y 0, x 12. Okay, so another one. So in blue line is, I put in blue, is 5x plus 5y equals to 60. And then another one, black line, is 2x plus 3y equals to 30. Okay, now we need to find the feasible region. So from the inequalities, so we know that this is less than and equals to, so means that it is down here. So the feasible region, we need to sheet the feasible region and label it as R. Okay, so means that this is a feasible region. Okay, now from the feasible region, we have to find the corner point here. So we got 4 corner points. Okay, it's 4 corner point. So make a table. Okay. And then here we put a corner point. And here is objective function. So the objective function is 60x plus 84y. So our profit goes to 60x plus 84y. Okay, now the corner point first is 0, 0, and then 0, 10, 12 0, and then another one is here. So for this point we need to find the simultaneous equation between these two equation. Okay, so we take this equation 5x plus 5y. 5x plus 5y equals to 60, so we divide by 5, so we got x plus y equals to 12. Okay, now we take this equation to substitute into another equation. Okay, so we know that x equals to 12 minus y is one equation, and then substitute into 2x plus 3y equals to 30. So we can substitute 12 minus y into this one function. So 12 minus y plus 3y equals to 30. Okay, and then you expand, so we got 24 minus 2y plus 3y equals to 30, and then we got y equals to 30 minus 24, which is equals to 6. So x equals to 12 minus 6 equals to 6 as well. So we got y x6 and y6. So if we take from the table, it's actually equals to 6 6. So make sure your graph is accurate so that you will get the correct point. Okay, now when you substitute x equals to 0 and 0 into the profit function, so you got 0, and then when you substitute 10, so you got 840. When you substitute 12, so you got 60 times 12 equals to 720, and when you substitute 6 6, so 60 times 6 plus 84 times 6, so you got 864. Okay, now the question asks you to find the maximum profit, right? So the maximum profit is 864. So how many type A share and how many type B share can be produced daily in order to maximize the profit? So you need to do the conclusion. Okay, so the conclusion here is 6 units of type A shares and 6 units of type B shares are needed to produce in order to maximize the profit. So the maximum profit is RM 864. Okay, that is the conclusion that we need to write. Okay, so that's all for number 1.